Okay, so this question is number 7 in the very first section here, and we're talking about slopes of secant lines. Okay, so a secant line is a line that connects a curve or in this case, a parabola at 2 points. Okay, so a secant line. Now, it gives you this right here. This is the function of the parabola that you see in this picture right here. Okay, I clipped that out for you. This is the parabola. And A says if point Q is on the curve, okay, and it's the point Q would be some x value, and then the y value, of course, is the description of the function. It's in terms of x here. But point Q is some other point, and this is how it's described. Find the slope of the secant line for the following values of x. So 7a1, or I, is when x equals 2. So you see over here on the diagram, with x equals 2, y is going to equal what? Y is going to equal 8. Yeah, and we could find that out if you didn't have the diagram right here. We could find that out by saying, okay, 2 and what is the y value? Well, it's 2 times 2 plus 2 squared. You see that? So if x is 2, then y is 2 times 2 plus 2 squared. And we have the point 2. That's 4 plus 4 is 8. Okay? So we have 2, 8. Does everyone see that? So this first part, they're just telling you what the second point is. And then what they're asking you to do is to find the slope between this point that we just plotted and the original point, which is 1, 3, right here. Okay? Yeah, I can't see where the yellow tip is before I write, so that's why it looks bad. Okay, so let's find the slope. Well, how do we find slope? If you recall, m equals y2 minus y1 over x2 minus x1. And so the slope between those 2 points becomes 8 minus 3, because those are the two y values, divided by 2 minus 1. So this is 5 over 1, or slope of 5. Okay, does that look right? Does that make sense? So we're finding the slope there. Okay, so basically you just kind of write that down. Okay, slope, fine. Now we move to the next one. What happens if x is 1.5? And so as you could probably imagine, we are getting this is a point that's a little bit closer to our first point. 1.5 would be right about here. Okay, so now we're finding the slope between this blue point 1, 3 and this one. So 1.5, that's going to take a little bit of calculation, so you might want to do that. So 1.5 squared, that's going to be 1.5, and that's going to be 3 plus, what's 1.5 squared? Anybody know that offhand real quick? 2.25, right. So 3 plus 2.25 is 5.25. So that should be this second point, and let's see, 4, 5, this would be 5.5. That looks to be exactly halfway between. So 5.25 is reasonable. We going good here? I'm going a little fast here. I am going fast, but are you picking this up? Okay. You might be writing rather quickly, but as long as you're understanding, that's my big thing. So what's the slope now between these 2 points, between this one and this one? Well, our y2 is 5.25. Minus 3 on top. And the x is 1.5 minus 1. So this is 2.25 divided by 0.5. When you divide by 0.5, that's just like multiplying the top one by 2. So that's going to be 4.5. Okay, so our slopes so far here are 5 and 4.5. Seems like it's going down. Okay? So what we do then is we take a look at what are the slopes when x is 1.1, 1.01, and 1.001. And we take a look at those slopes. So if we take a look at the slope here when x is 1.1, that should be a slope of 4.1. This next one, when you put x in here, as you calculate, that's going to be 4.01. And then this one here, the slope between the 2 points is going to be 4.001. Now if we take a look at the pattern here, right, because we're talking about We're talking about this right here, these 2 points, and then those 2 points, and then 2 points that are extremely close together, like 1.001 and 1, right? So they're super, super close. And this is the slope. So what's happening is these secant lines, and I'm not going to draw this very well here, but these secant lines are actually approaching a certain value. Now, I've actually got something set up for you over here. And where did it go? Oh, Desmos, Untitled. Nope, Calc 30 Desmos. Check this out. So this is your curve right here. Is that this one? Or is that 8? That's this one, right? 2x plus x squared, right? Yeah, that's it. Okay, so if I light up this right here, okay, this other line, okay, now look at what we're doing here. I've got this set up so that I can rotate this line a little bit. Okay, so 2, 8. There we go. See, that's the first one. Now don't worry about this or this. Don't worry about that right now. But that was the first secant line, right? As I bring the points closer together, as I move this little stick here, see how the points are getting closer together? And we're approaching a slope of, look at this, this is actually the slope here. So we're approaching a slope of what? 2, really close together. I'm getting really close to, so 4.03, look at that. I can't even get to 4.001. But you can kind of tell that, what does this orange line now start to look like? A tangent line. Yes. So as we bring the 2 points closer together, I'm just going to watch this. I'm going to play this. Look at, as the 2 points come closer and closer together, do you see how this orange line actually starts to approach the tangent line? You see that? Okay. So we cannot find the slope of a tangent line by traditional means. And by traditional means, I mean this right here, right? Calculating the slope like we did down here. We can't do that because we only have 1 point. But what we can do is we can try to envision what the tangent slope would be if I tried to pause it. Oh, I didn't pause it enough, but look at this. I'm going to try and pause it right there. Oh, not quite close enough. But do you see how when it's getting close there? There we go. It's going to approach a single tangent point there. And so, ever so slightly, if I move this over, 4.01, we have an approximation that is very, very close. Where's the... Oh, it doesn't show me the point. Points are too close together. Okay. Everyone see that? See, points really close. So, 2 things I want to tell you here, that we're talking about, this is actually a limit, okay? As we bring these 2 points together, the slopes of the secant lines approach a limit, and that limit, as they get closer and closer together, is a slope of 4. And we can't actually calculate that, but we can see by our evidence right here, 5, 4.5, 4.1, 0.1, 4.001, that we are approaching a slope of 4. And that is going to be the slope of the tangent line. Okay? So this notation right here, I just want you to write this down. And as you write this down, I'm going to explain to you that we are using now a concept of a limit. As the 2 points get closer and closer and closer together, infinitely close, they are going to, the slope of that line, that secant line, is going to approach the slope of the tangent line at P. So it looks like this. Limit, and we would abbreviate limit, L-I-M, and we are going to bring the 2 points, that is Q, closer and closer and closer to P. So as Q approaches P, right, just like in our, right here, right, as Q approaches P, it gets closer and closer and closer to actually that P point. And when we talk about the slope of PQ, as Q approaches P, gets infinitely close to P, what that approximates, everything on this side, what that approximates is the slope of the tangent line at P. At P, yeah, at P. Does that look like something else? Oh, you thought it was some fancy symbol you didn't know about? Oh, sorry. Sorry, I can't teach you anything super profoundly new today. Just P, capital P. Sorry, boring. We could put some Greek letter in there, I suppose, but whatever. So okay, so as the 2 points get together, the slopes of the secant lines approach the slope of the tangent. Now it's really important, this limit part and this arrow part, we're talking about getting infinitely close, but not actually talking about 1 point. As Q approaches P, it gets infinitely close. Okay, and so of course, if we just back up a little bit to this question again, I did not do the second half, but what you would do basically is you are now saying, okay, here's 1, 3, there's our original point, and now we're going to work at it from this side. Go to 0, then we're going to go to 0.5 right here, those two. Then we're going to go to 0.9, super close, 0.99, super close, 0.999999, super close, right? So you're looking at it from the other way as well, and that the slope of that line would also, you will find, approach 4. So this is going to be 3.999, 3.99, and so on, 3.9. And this will be probably 2.5, and this would probably be 2. Think. 3. Sorry. 3. 3.5, and then 3.9. Okay? So that's 7. I want you to do 8 just so you can kind of work that through and find out for yourself. But we're not going to do that right now. We're going to move on to what is a limit. More talk about a limit.